Start with our announcements. The first one is the film Sea of Shadows, and it is about the vaquita porpoise, the world's most endangered marine mammal. And it opened in theaters. It's a National Geographic film produced by Leonardo DiCaprio. Excellent film. We're going to be showing it here at the library on Saturday, November 2nd, 10 a.m. And he's here from the Marine Mammal Institute at Hatfield Marine Science Center. He's going to talk to us about humpbacks. So this is important with the hearing coming up about the humpbacks here along our coast.
I'll talk about that. Let me play with the lights a little. Oh, great. Thanks. Actually, if you can get these here, usually that's better. Yeah. Luca in the Strait of in Washington State. This is about 20 miles offshore. And the amount of time we spent picking up plastic bottles out there where whales are feeding, it's kind of horrifying. So one of them is that today is actually my second presentation at an ACS, a local ACS chapter. The first one I did was about 16 or 17 years ago at the Monterey chapter. I did my PhD here at OSU, and then I went to work. We made it work, and my formal position here, I'm an associate professor with OSU at the Marine Mammal Institute. Today it's all about the satellite telemetry work we do tracking whales, and specifically with humpback whales. And we have our group specializes on tracking large whales, and we are working with sperm whales and blue whales and humpbacks and grays. But and in various places around the world. But what I'm going to be talking about today is I thought would be most relevant for you guys is what are we learning about humpback whales of Oregon and Washington, and the reason for the rationale or the driver for a lot of this work will become evident. That has to do with the critical habitat and all the things that are coming up in terms of the conservation. But I wanted to ask. So, how many people think we have humpback whales of Oregon? How many? Yeah, like a lot of you guys. But have you seen them? Not my work alone. I work with a large team of people that we all do this work together. So, Bruce and Scott Baker, who runs the genetics lab, and then we have a fabulous team of research assistants that do a lot of the work for us. So the way that we can track whales over long distances, over long periods of time, the only way to really do that effectively and efficiently is using satellite telemetry. So in this case here we have, in that case it's a fin whale, and it's wearing a tag. There you can see the antenna sticking out. And then the tag, it sends a transmission, and that transmission is picked up by polar orbiting satellites, which is what you see in the bottom image. And they pick up the transmission, they hear the sound, the frequency that these tags transmit will shift depending on how the tag is, the satellite is traveling overhead. So by measuring how much distortion or the Doppler shift, that's how the satellites are able to triangulate the position of the tag and transmit that information back to land station, and then we receive that information. That's how we know. But that only works when the whales are at the surface. So right now, our latest design in tags is actually based on what we call a location-only implantable tag that, as I mentioned, has been in use since 1997. Looking at are very different. We're not interested necessarily looking at the very high resolution of what's happening over the course of the day. Schematic of the tag. So the tag itself is about 21 centimeters long, and internally it has the batteries, which is actually what occupies the most. It's 21 centimeters, but by about 2 centimeters wide. And the largest space is occupied actually by the batteries. It has 2, 3, 3-volt batteries, and then, as I mentioned, there's a number of sensors that are inside the tag, and then we have these antennas. One of them is actually a saltwater switch that detects when the tag is at the surface and tells the tag, okay, go ahead and send a signal. Animals from Central America, animals from Mexico, and maybe even animals from Hawaii coming to the West Coast, and they are all mixing here. And this is kind of a difficult situation for the regulatory agencies like NOAA, because they need to help, put in place regulations to protect the whales, but they need to know from which population they're coming. So unless we collect these data and provide this data to NOAA, it's very hard for them to do that. So it's very timely that this work we're doing right now is happening at the same time as NOAA is working through how to implement these regulations. And person there, I have a crossbow, and what I do is just after the tag goes in, then I take a biopsy sample, which is it has an arrow with a tip, and the tip will collect a piece of skin and blubber from the whale. And with that, we can tell the sex of the animal, which is very important to us. And we can also work out the genetics, which is also very important, as you'll see in a moment. And then there's other analysis that we can do that have to do with feeding. Basically, it's our fatty acid and stable isotope analysis. So we actually can collect a lot of information out of the sequence that you'll see in a second. And that's the one, the whale on the right, because that's the one we're interested in, right there. Boom, boom. So you can see the tag went in, and the air. So at that point, the driver immediately puts the boat in gear, and we just drift there. And then at that point, we have an iPad, and we start writing all kinds of notes about how the event went, collecting all the information about things we observed about the whales' behavior. We have to report all of that. So for this study, we have been doing tagging whales off Oregon and Washington and California, but don't say, since 2016. So that's the number of tags here in this column that we have been putting out every year. This year, as I mentioned, we put out 24. These codes are different kinds of tags we use. The DM tag, the one that I mentioned, covered in detail, we have been using for the last couple of years. All the other tags are sort of an evolution to get us to where we are with the most current version of the tag. And okay, so what I thought I would do is show you an animation of the tracks of all these whales. So since 2016 until present, where they went. And what you'll see you see the tracks, you see the whales moving. The colors represent the haplotype. So that's what I mentioned. We take that biopsy sample, and from the biopsy sample, we can run the sex and the haplotype, which is part of the genetics work. And we use that to come up with an idea of what population these whales belong to. And I'll touch a little bit more into what the populations are. But depending on the haplotype of these whales, we have a sense of which population out of the 4 that are known in the North Pacific Ocean they're from. Color. Then in 2017, we tagged a bunch of California, and they're mostly blue and green. That's the F2 and F haplotypes. Then we tagged off Oregon again in 2017. Look at this one. That's doing all these, all of the Northwest. Oregon, Washington, up and down, up and down. But then watch what it does. It's already going far offshore, goes in for one last refueling, and then we had the long migration that it did migrate along the coast. It migrated far offshore. Likewise, some offshore movements, even up inside during the feeding season, is actually not moving along the coast. They're spending a lot more time offshore than we thought.
let's say you had a tag on for 365 days. What would this track look like at that point? Would it be a
They would come back,
Mm-hmm.
and would love to do that. We have had one tag last 500 days on a blue whale. We the same data. This is more static but more difficult to see. But basically, yeah, those animals that we tagged off Central California. This is San Francisco here, Monterey Bay, and they spend a lot of time here. But they didn't really come up, except for that one that came up, that blue one that goes up and down. Most of them stayed here. Here, an area that before wasn't known to have many humpbacks there. Now we're seeing quite a few there. And then off our Oregon coast. And you'll see that off Central Oregon especially, there's not much real close to the coast again because we have a wide continental shelf and they really like to hang out along the shelf edge. So why is this work important and what is the relevance? So in 2015, NOAA established 7 biologically important areas for feeding humpback whales on the west coast. There's one in Washington, up there, just outside of the Strait of Juan de Fuca. Then Stonewall and Hecata Bank in Oregon, just off here at Newport. And then Point St. George in Northern California. So there's one in Washington, one in Oregon, and then there's 5 in California. So Point St. George, Northern California, Fort Bragg to Point Arena, and Gulf of the Farallones to Monterey Bay. These are Central California. And then in Southern California, we have these 2 here near the Channel Islands and Point Conception. One of the things we do with the tracking data in this case is we combine all the tracks, and what you see in colors here is a combination of what's known as the home range. So once you have an animal, so like imagine you go between here and Fred Meyer and come back, and then you can sort of draw an envelope around that, and that's called your home range. And maybe Nolly has a home range that it's mostly from in Nye Beach. That's where she hangs out, and maybe Jeff and Steve go all the way out to the hinterlands every day. But yeah, each whale has a different home range. But if we combine them and overlap them, what we see in the different intensity of this shade is that the darker shade is where you have more whales were found in that area. So it gives us an idea of the importance of different areas during the tracking period. Area that was designated generally captures that, so we could say that it's pretty well placed, but if anything we see that there's a lot here inside the strait that is not really captured. Another aspect there is that there's a lot of ships that are coming through that Strait of Juan de Fuca. The river, there appears to be some indication that it's an important area for humpback whales. That hasn't been yet identified as an important area. This one is spot on. You can see it's really good. Likewise, this one, Point St. George in Northern California. This area pretty good. This one is excellent. This one is the Gulf of the Farallones to Monterey Bay. This photo from Craig just a couple weeks ago. There's a lot of commerce ships from tankers and container ships going in and out permanently, and they just happen to cross right through the area of aggregation of humpback whales. So anytime you have human and animals, there's a potential for risk and interaction. And one of the reasons that this work is being done and humpback whales have come up to the top of scrutiny and attention is because their populations are not recovering, and in this particular populations. What they're doing there. So in this case, what you see in colors for the same areas, northern Washington, Oregon, and California, the yellow, the bright yellow colors is where the whales are diving, spending more time at depth, longer dives. Longer dives is usually feeding times where they're feeding. So what you see is that not the whole area is one color. So we're seeing a lot of patchiness, and that's important too, because even in an area that's important for the whales, you can tell that, let's just look at this case, it's pretty clear. This area here is where they're doing most of the feeding, but there's blue areas here that they may be areas where they go and maybe spend more time near the surface, resting, or something like that. So it just enriches our information about what we can say about these areas. the black boxes are the dark hours, so from 8 p.m., 8 p.m. across the night into early morning. Those are times when the whales are generally making shorter dives. But then during the day, you can see that there's an increase in the duration of the dive. So that means that they're mostly diving longer during the day, which is the time when they feed. This last year, which is interesting because obviously most of the feeding happens at depth, but also at the surface. Okay, so I kind of like gave you an idea of what the data mean to us on a regional context, but now what does it mean on a larger global context? So who knows how many humpback whales do we have in the North Pacific Ocean? This is about 17 or 18 seconds of a tagging sequence just taken a couple weeks ago. And this is typical of our operation. Everything happens really, really fast, and everybody has to be really on it, on focus, because everything has to work just right. So what you'll see here is two whales. We are approaching them, and we're going to tag this one here. This is actually going to be the one on the left. There's another whale further out, and we have to come up very close, parallel to the whale, and just at the right moment when we are exactly parallel, if everything works all right, we can put the tag on. So we won't put the tag on the whale unless everything is just right, because we want the tag to be placed as well as possible so that we can get the longest duration possible. Well, that how many whales were killed every year from the whaling industry. They recorded all that information, and it's well known that some of that information was falsified. But there's been a lot of efforts to revisit the data and make sure that it's as accurate as possible. So after doing that, what statisticians do is that they have a population model that has been developed for animal populations that we know work pretty well. So you plug in those numbers, and that's how you're able to trace the population. Those are estimates. So they usually give you an estimate along with a confidence interval to say, okay, well, in 1820 there were 50 whales plus or minus such. And that's how they were able to separate. And what you see is, so each of those pies is the number of, the proportion of the different haplotypes of the whales. So what you see generally is sort of a gradient, a transition between going to mostly green here, to kind of like a mix of blue and green and yellow and maroon, to mostly yellow and maroon, and then to mostly blue and green here. This is from that study, Splash, in 2000, during the mid-2000s, and these are the proportions of haplotypes for California, Oregon, and for British Columbia and Washington. So far, collected samples in California, and we collected 14. We collected samples in Oregon, and we collected samples in Washington. So this is pretty exciting for us, because what we're seeing is that where the Splash study grouped California and Oregon into one single population, what we're seeing is that, yes, California itself is falling out and being different, but Oregon does not group with California anymore. It's actually, Oregon is more similar to British Columbia and Washington. So that the Washington animals, what you see is that it's mostly gray bars. Those are 24 different bars. It's mostly gray bars and a few orange ones. So that's a lot of animals that appear to be coming from Hawaii. And this is not sure. It's not absolute. It's a probabilistic assignment. Then in Oregon, we're seeing mostly animals from Mexico and Central America, which are the yellow and orange. And then in California, definitely mostly Central American. So again, all these lines of evidence are supporting a little bit more refined understanding of what these populations of the West Coast are. NOAA is in the process of helping address the conservation status of whales of the West Coast of the U.S. So this is my second reason to brag about, is that what you see here is the Federal Register announcement that came out on October 9th, that there's going to be a designation for critical habitat of the West Coast. This was the result of a whole year of work, and we were invited to be part of the group of experts informing NOAA with our data, the tracking data, all the tagging data, to identify, and I apologize that you can't really see very well, these are all boxes. So what NOAA did is they started number 1, number 2, there's 19 boxes in U.S. waters, there's 19 here. And there's going to be people from NOAA, from DC headquarters. That's a good way if you don't want to read like 80 pages of this document. They will present the main conclusions and why they're justifying this. Because this will eventually become federal regulation. It's open for public comment until December. So coming to these hearings and listening and providing your feedback is very important. Again, up in the Strait of Juan de Fuca, there's also cruise ships coming through, and yeah, just human activities. Obviously, the economy is doing really well, and there's more human uses of the marine environment that also brings more conflict with wildlife. This was NOAA. Last year, they were doing some work out of Neah Bay as well. They were on the water, and they were flying drones, mostly to study gray whales, but they saw humpbacks as well. And if you squint, this whale actually has one of our tags, which is the reason why Jeff Harris from NOAA again say that a lot of this work is possible through a lot of contributors and assistance from people at OSU. Minda's here. She has been great support for us in our program, and yeah, a lot of people have made this possible. Also, when we work up in Washington State, we have to get permission from the Makah tribe to let us work in their waters. Those are their waters, so we have to clear that. So, subpopulations, because when you look at a whole hemisphere population, maybe the population is doing reasonably well. We generally feel that, except for right whales and a few other whales, as a species, most species are generally recovering pretty well. But when you look at individual populations, why are some populations not recovering so well and some are doing really well? So the general consensus in the science community is that those populations that are not recovering well is because they are interacting with human activities in strong levels.